Okay, so now we'll look at a real-life example of a while loop. So this will be kind of like a little imitation of a video game. So this will be kind of where you might see a while loop in the code itself. And yeah, so we're going to be talking about a video game, particularly a game like Mario. So hopefully by the end you'll kind of understand what we mean when we talk about game loops. So these are just going to be loops, while loops, that kind of, when they loop through with each iteration, they do a bunch of checks and updates, and basically they run until, in our case we'll say we'll run until we run out of lives. But we'll get more into detail with that, and so yeah, we'll explain game loops, take a look at while loops in video games. Okay, so now we've had our intro into while loops, let's see one in action. Okay, so we're going to use the example of a kind of like a video game, and this is going to be a very common place we'll see while loops. I'll just go through this small example and then I'll explain the kind of bigger picture with while loops in the sense of a larger video game. So what we're going to do is we're going to have a player and an enemy position, and we're just going to move them closer and closer together until they're touching, at which point we'll kind of initiate some kind of game over sequence. So let's create some variables first. The first one is going to be a player position, and let's just set this equal to 5, and then we'll have an enemy position, and we'll just set this equal to 10, and then we'll have, yeah, that should be pretty good. So what we're going to do is we're going to say while, you know what, let's create this other variable. I'm going to call this lives, and I'm just going to say it's equal to 1 for now, so we only have 1 life left. So we're going to say while lives is greater than 0, so basically while we still have a life left, we're going to subtract 1 from the enemy position, because maybe the enemy is kind of moving closer to us, and then we're going to, what else are we going to do? We're going to test to see if player position equals enemy position, and if it does, then we'll subtract 1 from lives. Okay, so what appears to be the problem here? Expected expression after operator. Oh, there we go, that's why. Okay. So now exactly what is going on here. So we have a lives variable which is starting at 1. We have a player position and an enemy position. So the player position is going to be the position of our character, and the enemy position is going to be where the enemy is right now. So with each iteration of this loop, we're checking to see if we still have a life left. So as long as we have more than 1 lives, which means that lives is greater than 0, we're still going to run this loop. So this loop could run thousands of times as long as we don't actually ever collide with the enemy. So each time we're subtracting 1 from the enemy position, and each time we're also testing to see if the player position is equal to the enemy position, which means they're touching. If they do touch, then we'll subtract 1 from lives, and we'll go until lives is greater than 0. So this is a very small example, a very small and simple example of where we might see something like this. So with each what we call tick of the game, everything kind of gets updated, so maybe the positions change, and in this case we have an enemy moving towards us, and so we're going to keep running the loop, we're going to keep moving the enemy forwards towards us until they touch, and at that point we'll have lost a life and we'll be at 0 lives, and then we can exit the loop. Okay, so that's what's going on here. We are basically just running until we run out of lives, and each time this runs, it just checks to see whether the positions are the same. Okay, so you can think about this in the sense of kind of like a Mario game, where you have like a Goomba and a Mario, and once a Goomba and the Mario touch, you lose 1 of your lives, and you basically keep playing the game until you're out of lives, and then it's game over. Okay, so that might be a good place where you'd see this. If we want to just see this loop running, what we're going to do is we're just going to say new position 1, and we're just going to have print enemy position each time, and it's just going to run, and then we'll see it print out. Okay, so there we go. So the enemy position starts at 10, And so the loop runs a first time and subtracts 1 from the enemy position, so that's 9, and then performs this check. Well, that's not the case yet, so we'll do 8, so we'll run it again, subtract 1 from the enemy position, and then 7 because it gets closer, then 6, then 5, and that's a point at which a player position and enemy position are equal. So then we lose 1 from our lives, and then the loop recognizes that lives is now no longer greater than 0 because it's equal to 0. So then it exits, okay? So we get this loop running 5 times. And that's because we're going from 10, subtracting 1 each time until basically this equals 5. Okay, so that's the loop in action there. That's how it's working. Again, it's going to be, we're going to see a lot of this kind of stuff in games. So the reason we would use a while loop is because we don't actually know how many times this is going to run. I mean, in our case, we know exactly because the position starts out as static and kind of is just changing by 1 each time without kind of a user input. However, if the user was moving the player around and the enemy was just kind of moving back and forth, we might run into the situation where the player and the enemy actually never touch. I mean, think about a Mario level. If you go through the whole thing without touching a Goomba or anything once, then this while loop will technically never end. So that's why while loops are so great for these games, because each time it iterates, it performs a bunch of these checks, and if any of those checks happen, then it's going to update something. Or if any of those checks pass, then something gets updated each time. And again, this just kind of allows you to run this loop over and over again without knowing necessarily how many times it's going to run. That's really the beauty of while loops versus for-in loops. Okay, so looking at this in the big picture, this was only a small part that had to deal with positioning, but really there could be a lot of different things. So while we are running this loop, so while lives is greater than 0, which means we're checking to see if we're still in, we could perform checks like positioning of the enemies relative to us, which is what we're doing here. We could check positions off, if we're thinking about Mario, we could check to see whether we're touching a coin, or we could check to see whether we're jumping, and stuff like that. So that's where we'll see while loops a lot, and we call these game loops. So these are basically just these while loops where there's a bunch of checks being performed. So, for example, are the enemy and the player touching? Is the player and like a coin touching? Has the player, in the case of Mario, has the player run into like a mushroom or something and grown in size? And stuff like that. So this is where you'll see these while loops. Basically just these loops that don't have a specific definite endpoint every time and can keep running until a certain condition is met. Okay, so that's while loops for you. Again, it's just going to run until this condition is no longer true. So until lives is no longer greater than 0, that's when it exits. As long as lives is greater than 0, it's just going to keep running this. It could run infinitely, or it could end right away if this position was, 5 and 5. Okay, so that's how they work. Think about the idea of while loops within video games, where we're just kind of performing these constant updates with each iteration of the game. Okay, so if there's still a little confusion between while loops and for-in loops, go back and watch the for-in loops video, or the tutorials on those, and then compare them to while loops. And you'll see that while loops are definitely less restrictive, but can also cause errors. Like if we're not careful, we could have this loop running infinitely, and that would cause the code to crash. Okay, so again, it seems that when things are less restrictive, so when you have more freedom within the code, they're more error prone, which means that you could kind of go out of bounds, or you could run into these infinite loops. So just be careful of those things when dealing with while loops. Okay, so that's while loops for you. We'll just introduce a couple more things that we can do with loops, such as break statements and continue statements, and then that'll be it. Okay, so we looked at the example of a while loop with kind of a video game feel to it. So more specifically, we considered a Mario-like video game in which we have a player who's changing position and an enemy who's changing position, and when they touch, that's when you lose a life, and if you're out of lives, that's when you exit the loop and end the game. So this loop kind of allows the code to run and perform various checks with each iteration, and that's what we call a game loop. So you'll see a lot of these, particularly in these kind of like Mario style video games, where it just kind of runs and performs all these checks and updates until a certain condition is met, and that's usually some kind of a game over condition. So that could be when you run out of lives, or when you run out of time, or maybe when you win the game, like you complete a level, it will kind of exit the loop and load the next level. Okay, so you'll see a lot of these in video games. Perhaps it might be a good idea to, if you're playing video games from now on, kind of look out for these loops. So look for these behaviors that repeat themselves over and over again, and try and think about what the code might actually look like.